All right, here we go. So we're going to solve equations today, and we're going to talk about two kinds. We're going to talk about an exponential equation, and we're going to talk about a power equation. And the difference between the two, an exponential equation has a number for a base. So the exponential has a 2, a 3, a 4. It's going to have a number for the base. A power equation has a variable for the base. Okay? So when I look, I have 16 and 8. So those are numbers. So this is an exponential equation. And so just like what we were doing with our exponents when we did the rational equations, we have to make the 16 and the 8 its smallest number. So 16 and 8. So 16 is 2 to what power? 4, yes. And 8 is 2 to the 3rd. I'm going to take the 2 to the 4th right here, and I'm just going to substitute it for the 16. So I get 2 to the 4th, and then I have 3x plus 6. And then I'm going to do the same thing for the 8. I'm going to put the 2 to the 3rd, and there's just an x there. When the bases match, we can just set the exponents equal to each other and solve. So I'm going to distribute. And once I distribute to solve, I have to put the variables on one side and the number on the other. So I'm going to go ahead and subtract the 12x. So we have variables on one side, number on the other. I'm going to divide by -9. And then I have to reduce. When I reduce by 3, I'm going to get -8 over 3. Okay? So now I have 1/9 and I have 27. I have 1/9 and I have 27. So first of all, I want to use 3. So 27 is 3 to what power? 3 to the 3rd. Good. Now, what is 9? 3 to what? 3 to the 2. So it's 3 squared, except this is in the denominator. How do I get it to the denominator? What do I make the exponent? Make it what? Make it negative. So I'm going to get 3 to the -2. Did you say it, Jose? You need to say it loud and proud then. I'm old and deaf. I can't see anything. I can't hear anything. Okay. Do I care if you're right? No. You got to try. That's all we care about. We don't care if you're right or wrong. We're trying. That's it. All right. So 3 to the -2. I'm going to go ahead and substitute this in for 1/9. I'm going to substitute my 3 to the 3rd for my 27. Do my 3's match now? So now we can set the exponents equal to each other. So I'm going to have -4x minus 2 equals 3. So I'm going to add 2 and divide by -4. All right, y'all try example 3. You have to do what I just did. We have to do the 1/16 and we have to do the 32. Okay. Micah, what did you get for 1/16? 2, look at me. 2 times 2 is times 2 times 2. So if 16 is 2 to the 4th power, and I want to move it to the denominator, what do I do to the 4? Okay, so then I have 32. That's going to be 2 to the what, Shelby? 2 to the 5th. So then I'm going to go ahead and substitute these in. I'm going to have 2 to the negative 4x equals 2 to the 5 times 3x minus 1. Now my bases are the same, so I should have had minus 4x equals 15x minus 5. I'm going to subtract the 15x. And divide by negative 19. And a negative divided by negative gives you positive. Is that okay so far? Everybody's all right? Okay. So so for the next example, y'all, I've done this a couple different ways. So I think the easiest way for me to show this to you, first of all, this is the square root, correct? And that means the index is 2 and the power on 8 is 1. So I'm going to write it as 8 to the 1/2 times 2x. Does everybody see what I did? I just changed the square root to 1/2. And why do you think I did that? Right, because, and I think somebody started saying it, y'all, if I take 1/2 of 2, what happens to these 2's? They cancel. So now I have 8 to the x times 2 to the negative 9, and then 16 to the negative 6x, and that's way better than with the mess, right? So 8 is going to be 2 to what power? 2 to the 3x. And then I have times 2 to the negative 9. And we already said 16 is 2 to the what? 4 times negative 6x. Now these are multiply on this side, correct? So I'm going to go ahead and do minus 24x. And y'all, what do I do with my exponents when I'm multiplying? I add. But in this case, it's a minus, so I'm going to subtract, right? So I'm going to have 3x minus 9 equals negative 24x. I want the x's on one side, the numbers on the other. Bless you. And then I'm going to divide by negative 27. And when I do that, a negative divided by negative gives me positive. And when I reduce, I get 1/3. Okay, so the next thing on example 5, I have 3/2 raised to the x. And so I have 4 and 9. So can I write my 4 and 9 as 2 to the 2nd and 3 to the 2nd? That's my smallest. Does that make sense? Okay, so now I'm going to write this like this. Do these match? They don't. Are they close? So can I pretend like they match and just solve it? You cannot. Where do I need my 3 to go? And the 2 needs to go. So what if I did, instead of positive 2, what if I said, what if I made it a negative 2 and I switched them? Do these match now? And now your answer is x equals negative 2. I know. Easy peasy. And y'all, this is, I've seen this on the SAT before, where you just have to switch them and get your answer. Okay. So what do you notice different about the next example? One's an x and one's a number. So this isn't exponential anymore, right? All right. So now what I'm going to have to do, how do I get rid of, if this is 5, how do I undo to the 5th power? Do what? Okay, yes. Can I do, so along that lines of thinking, because you're saying get a 5 on this side, okay? And then you could match the x in the answer. Exactly the opposite of what we just did. That's smart. So if I have x squared, how do I undo x squared? I square root it. That's to the 1/2. If I do x to the 3rd, how do I undo the 3rd? I cube root it, which is 1/3. So if this is x to the 5th, how do you think I'm going to undo x to the 5th? 1/5, right? I'm going to do the reciprocal. So here I want to the 1/5, and here I want to the 1/5. So now on your handy dandy calculator, I want to take 289 raised to the 1/5. So I'm going to type 289, and if you look right next to the x squared button, there's an x with a little box. You see how it put a power there for me? But I want that to be 1/5. So I'm going to use my little fraction there, and I'm going to do 1/5. Does everybody see that? And if you did it right, here's our answer. I got 3.105843, blah, blah, blah. Okay, now we are gonna round to the 3rd place. So I want to make sure all of you understand, because if you're rounding wrong, I'm going to count them wrong on your test. Look, to the 3rd place. 5 is in the 3rd place. What is next to the 5? Round up or round down? So my answer is 3.106. And on the test, if it's not 3.106, it is incorrect. Okay, so next, example 2. I'm going to subtract 1. I need to divide by 4. Now, I have x to the -7th equals 37 over 4. I want the exponent on the x to be a 1. It has to be a 1. So if it was just a 7, what would I multiply by? 1/7. And it's negative, so what does the 1/7 have to be? So I'm going to do -1/7 on both sides. So on this one, just to be sure, I'm going to put it in parentheses to make sure, but I have 37 over 4, and then I'm going to put the parenthesis. You see how I put it in parentheses? So I can raise it to the power, because I don't want just the 37 raised to the power. I want the whole fraction raised to the power. So then I added my little fraction. Do you see that? And the fraction this time is also a fraction, right? The exponent is a fraction. And so the negative is right here. So I'm going to have -1/7. Does everybody see that? When I push equal, I got 0.7277. The 3rd place a 7, and I have a 7 next, so I'm going to be 0.728. Okay, so this is another one like number 5, and it's way easier than it looks, but you have to be careful. So look at the negative 2x to the 1/2. On the negative 2x to the 1/2, the 1/2 is only on the x. It's not on the 2, right? But on the next one, this says the 9x to the 1/2. So this one, what is the square root of 9? 3. So now I have minus 2x to the 1/2 plus 3x to the 1/2 equals 2. And I did that because the 9 was inside, but the negative 2 is on the outside. So I didn't take the square root of that, only the 9. And so when I do that now, what's negative 2 plus 3? So I get x to the 1/2 equals 2. How do I undo 1/2? So I'm going to square on both sides. And when I do that, I get x equals 4.